Good morning and welcome to this webinar. We are discussing the use of AI in traffic management for the next 2 hours. I am Joanna Zanidaki. I'm the Chief Innovation Officer of AI Consulting, and I have almost 20 years experience in ITS. I have been leading the TM 2.0 innovation platform on interactive traffic management for 10 years. And I'm very happy to have a fantastic panel with me to discuss this very important topic. But before we start the discussion, let me give you a bit of information on the format of the webinar. So we have 9 speakers. We are trying to approach the topic from different perspectives. We have speakers discussing about projects, innovation projects funded by the European Commission. We have 2 innovative SMEs. We have POLIS, which is the European Association, but we also have EIT, or 28 Digital, as it's called now, with whom we are co-organizing this webinar. So 2 European associations. We have an RNI Tech Center. This is our first speaker. And I hope I'm not forgetting anyone, but we are trying to touch all the points there from the different perspectives. Of course, if we are missing something, we will find out at the Q&A, which is happening at the end. So what we're doing now is going to have short 8-minute impactful presentations from all the speakers, and then at the end we are going to have the Q&A. You are all muted and your cameras are off, so it makes it easier for us to see who is presenting and so on. But with you can send us the questions through the chat that you see on the top of your screen, and then I will be reading them. So just to introduce a bit the topic, I don't want to go deep in that, but we are discussing about AI, the use of AI in traffic management, and this is a discussion that is taking place for quite some time. I have been organizing special interest sessions at the ITS congresses and other events, and some of our speakers today have been with me in this journey. We have a task force in the TM 2.0 platform. We are discussing about the AI Act and how the AI Act is kind of dealing with traffic management, putting it in the high risk category of systems using AI. And what does this mean? How safe it is for us? Are we allowed to use it being a high risk under the AI Act? And does it actually jeopardize the fundamental human rights? And on the other hand, we will discuss the benefits that AI brings in traffic management with the speed that it helps us collect information, do the data analytics, predictive traffic management, dynamic traffic lights, incident detection. You're going to hear about all that. But let me already, I think I mentioned all the rules, and let me already pass the floor to the first speaker, who is Dr. Oyana Ota-Egwe. I always have to be slow in saying your surname, Oyana, but she's Director of Transport and Security at Vicomtech, and she's going to share with us some insights from the use of AI in traffic management at the level of research and innovation and CCAM. And Oyana, the floor is yours. You can start taking control. Super.
Okay, so thank you very much, Johanna, for inviting me to this very interesting webinar. I think that this is of top importance now that we are talking about traffic and that we are talking about CCAM and new mobility services. And yes, so I will be giving a brief overview on what it's all about in traffic management for a general perspective. I am not going to go into detail on a specific projects. I think that this is going to be done by all the colleagues that are also invited to give a talk in this session. So I will try to give an overview on what has been going on in the past year. So First of all, to tell you why I am doing that is Johanna already told that I am the Director of Transport and Security Division in BeaconTech, where we are working since more than 20 years in all that links to data, let's say multimodal data analysis to all the mobility and transport pillars. So from developing sensors to measuring infrastructures, vehicle, deal with data coming from all those systems to backend, and then do some kind of analytics behind to understand what is going on and to do what the control engineering does. So take some kind of actions in order to maximize some specific KPIs that we want. So we use the technology as basis, and we apply that to different subsectors of transport and security. And of course, the traffic management is one of them. Okay, and traffic is so I'm not going to tell anything new. So traffic is one of the major problems that we have in cities and big urban and suburban areas in Europe and in most of the world. And we have been working to try to get that better by digitalizing it, by learning or trying to understand what is going on for taking recent decisions on managing it. So especially now that we are also talking about SICAM, about the integration of new mobility services, talking about the potential automated system for or semi-automated or some kind of smart vehicles entering this somehow complex infrastructure, this is something that is quite important. And it's not anything new. So we have been doing this, and it has been the basis of strategic research agendas for more than 20 years. So Johanna mentioned that she has been working for almost 20 years in ITS. So I remember when in early 2000s, we start with the definition of the ITS system. So how to really digitalize and get data to do some kind of a smart transport management system. And this is what we started to do in the early 2000s. So try to understand how we could take a decision more efficiently and specifically basis on measurements. So traffic management, and I think that we will see afterwards in each of the specific projects and activities that the colleagues are going to be showing. So the first thing that we need to do is data collection. So we need to get some kind of sensors to measure and to generate data that is useful for taking decision or for understanding why is this happening. In the last 20 years, I can tell you that all these sensors and the communication have evolved a lot. And now the data amount that we are generating is huge. With this data, what we have been doing since more than 20 years is this data analysis. So business intelligence, somehow try to understand or extract from this data what is going on, what is going to evolve, how it's going to be evolving this situation. And then the humans behind these screens in the traffic control, they take some kind of decisions on how to actuate. And this is then transferred to information to the drivers, the traffic lights, or the information panels that are in the infrastructure in order to ensure that all the actions are taken by the road participants, and then we can have some kind of the desired action in the or actuation in the traffic and in the road. So this is basically what we have been doing, but with the introduction or the explosion of the AI capabilities, what we have just somehow enter a little bit or somehow adapt a little bit is how we are dealing with this all data that is being generated. So yes, AI is also in the census, but I am not going to go into that. I am going to focus only in the traffic management. So we are getting more and more information, and it's really difficult to, with some kind of rule-based or a statistics prediction on time and geographically or geographical information, trying to get those insights, real insights, to take a better decision. So the more information that we have, the more difficult that is getting, or that is for the traditional methods to be really good at analyzing and providing prospection on how it's going to be evolving. And this is solvable, and this is the strength of the AI algorithms. So with the AI that is data-driven, we can really get better algorithms, better approaches, and better analysis and better understanding of what's going on. So in the past years, we have been seeing a lot of activities, a lot of projects where we have been involved, and the ones that you are going to be seeing afterwards, that are already applying AI, and that we can see how it's positively impacting this sector on traffic management. But what happens? So it was already said at the beginning. So yes, we have been using AI, but in Europe, there is this AI Act analysis, and this has an impact. An impact on both sides, on research side, and also on the deployment of AI containing systems. So it's true, it's a legislation model, and it's based on risk analysis, okay? And the problem is that it's been done sectorially, so this analysis has been done sectorially, and in the sector where the safety of a human being is some kind or potentially affected, this means that the whole sector is then noted as high-risk sector, which has, or which comes with a lot of somehow extra limitations in terms of how to integrate the AI system. And for me, what is really important is to really ask or to analyze whether the sector is a problem or a high-risk sector, or the application itself is a high-risk application. Because in traffic management, at the end, there are humans taking some kind of control, so they are the ones reading the outcomes of the AI. So it's not directly the AI taking control of the whole traffic control. And additionally, although in research, we might do some kind of new approaches, so we have higher freedom to do that, because we have some kind of exemption in applying AI. But if we are only doing this exception in the AI, then the deployment of these very good results on AI on AI and research project cannot meet the market. So this is something that I think that needs to be taken carefully into account. And with this, I would stop my brief presentation to the topic. Thank you.
Wow, thank you very much, Oyana. Honestly, you touched all the points. I'm very grateful to you. Indeed, we are discussing the impact of the AI Act and in both sides, research and operations. And the point that you made, that AI does not take control of the entire traffic management, is very important. I mean, it's going to be discussed by the other colleagues as well. But what I liked was the most is the word explosion, the explosion of AI capabilities. Indeed, it's an explosion of data, and then we have the explosion of AI capabilities helping us to do things faster. Thank you very much, Oyana. Don't do anything. I have to pass the control to Professor Claudio Roncoli, coordinator of the Acumen project, which is an EU-funded project. He's going to talk to us more about it. And Professor Roncoli, or Claudio, is a professor at KU Leuven. So the floor is yours. Thank you.
Yeah, thank you very much, Johanna, and thank you very much for inviting me and for giving me the chance to tell you a little bit about what we have been doing in a European project, Acumen. And I also thank very much Oyana, because she set very nicely the scene for some more concrete results that, let's say, we have obtained within the project. Well, very briefly, a couple of words on the on Acumen itself. So, well, the title already. Well, first word is AI. So we work basically in developing a set of tools for analyzing and improving, let's say, multimodal network and traffic management. So we started already more than 2 years ago. And we are then in the last year of our project. And so we have already having quite a good set of results. And we are research innovation actions. We have 17 partners covering academia, industry, and different other organizations. So just to give a bit of context, basically we try to look at the multimodal transport by developing different tools in different angles. And from what you can see here, so we looked into different aspects about data analytics. So what kind of AI tools we can actually use and how they can actually help us in taking better decision, understanding better what happens. And then we looked at forecasting models, and I will show you actually here an interesting example that fits very well the discussion that we said before about still having humans involved, and then a few words about some specific application about management where we actually close the loop, and in particular what we think also future traffic management is going to be. Yeah, so if we look into data, of course, we have this challenge in traffic and transport. We deal with, of course, big data. That's true. But a big challenge of this data is also sparse data, incomplete data, and very often, so from the data we actually have, we see just a little part of the system. So the challenge that we basically try to look here is how can we actually leverage AI tools for actually trying to capture and explain better these complex interactions that we have between the different traffic modes and services that we have. Like, for example, some disruptions in the traffic system on some road traffic may also affect the bus traffic, the tram traffic, and maybe also the efficiency level of some other public transport service. So how we can actually study this through some methods. Of course, that's very, very difficult through the more conventional methods because of their limitations. But here AI can actually play a very, very big role in trying to reveal and to explore these complex interactions. And here, for example, well, we look at in different cities, but so the case we actually had in Helsinki was indeed to build some AI model that it's basically trying to put together the data from, for example, from crowding on passengers, on buses and trains, together with road traffic data, together with usage of other micromobility services, and try then to better understand what are the impacts of the different services and the different disruption on the service on one another. And that opens definitely the way for more advanced traffic management involving multimodal services. And then another important case that we look when about data is also using it for incident detection. Again, we may not, what we want from our traffic management centers is to capture as soon as possible an incident happening and adopt meaningful interventions. And so also there, what exists. It's conventional methods we're not really able to capture in so much details as we can actually do with AI. So we develop a method. In this case, we developed in a case study in Athens, where we basically, through a combination of different AI techniques, we could achieve a very, very good performance in terms of incident detection and location detection, and also forecasting of the impacts of a certain accident. Now, in relation to a major problem that was indeed mentioned before, that of course we still have humans in the traffic management centers, and we still want humans to take certain decisions. Of course, here the challenge is that AI, even though we have been studying it for a long time, it's still a relatively new technology that's still not fully understood to some degree. So what we try to work is also this human in the loop in the AI context. So the idea is basically how we can actually help as much as possible humans to interpret well the results obtained through some AI models, and how they can actually take proper intervention based on them, and when it makes sense to really trust these results or not. And that, of course, comes from the fact that AI there are statistical models, so there is always this uncertainty component there. And basically, so what we basically are trying to look at here is, what if we actually provide the humans also this kind of information, the humans, the operators, also this kind of information about how we are actually supposed to trust the model now. So some sort of threshold of uncertainty, where basically we can tell the operator directly, well, this is a very good, we believe this is a very good prediction, versus this is a prediction which should be taken with more care. And then, of course, the operator may have different choices. It can use more simpler model, for example, if that's not trusted or not. So that's a very important dimension, really, how to use these AI tools. And then the last item that I want also to bring to the picture is that, of course, not all traffic management for the future is going to be hard traffic management with signals and then traffic signals and safety-related applications, but that we are also looking into, this also opens the opportunity of looking into what we call soft management strategies. And for this, we're looking, for example, how we can combine these soft and more traditional hard strategies. And by soft strategy, I mean incentivizing different use of modes, incentivizing different routes, promoting different alternative options for transport. So on that side, of course, the criticality of AI is definitely much less critical than in typical studies. So just to wrap up, so as my time is expiring, I guess, is that, of course, AI is a very, very good tool with a lot of potential, but we need to acknowledge and understand very well the many flavors it can come with. And of course, impacts and risk depend strongly on the application that is used, and that's something we are clearly seeing as the result in our projects. And what we believe is extremely important, and what we are really pushing to understand better in this project is how to incorporate in the EI prediction results, models, etc. What are the limitation and uncertainty of that specific tool? And that's it from my side. Thank you very much.
Thank you, Claudio. Thank you. I like it that you took the traffic management road-based usually, and you elevated it into this multimodal traffic management, which is very important, because road traffic is not only the cars, it's a multimodal network that we should be looking at, and indeed, multiple data sources for multiple modes, and AI is a great tool, and I really like the the focus that you're placing in Acumen on integrating the human expertise and how you're comparing the two and how you are using it to enhance the model's performance. Let me pass to the next speaker, Dr. Manos Barbounakis, who is the co-founder of Mobilises from EPFL, but he's also, or Mobilises is also a partner in Acumen, but also a partner in Delphi, which is the three-step project, and also a partner in Metacase or Metacase, it depends how you pronounce it. And all these three projects are working on the use of AI in traffic management. And Mano, you're discussing how drones are, the use of drones and AI in traffic management is reshaping the field. The floor is yours.
Exactly. Exactly, Joanna. Actually, it's a great opportunity that I even get to talk after Claudio, because he did all the difficult part, which explained all the fancy slides with the AI traffic management scheme. So now I will go a little bit deeper on the data side of it. And as you correctly said, we are participating in Acumen. We are also participating in Delphi. And we are leveraging AI with drone technology as well to see how we are tackling the challenges that we have identified. But having said that, let me a little bit start off how we are experiencing the problem of traffic management. So indeed, traffic management is a huge problem. And not only it's a huge problem, but we see that it's getting bigger and bigger all the time. And while in the past it was quite straightforward, you wanted to go from A to B, you would take your car, you would go to B, park there, and then you would go back. Now things are not as simple as that. We have many different options, many different stakeholders. We have new technologies coming in. We have different data providers, all of them competing and collaborating at the same time at a limited space, right? And while cities are trying to tackle this problem, we see that they mainly prioritize vehicle management, but at the same time, they're trying to do it with tools that are car-centric. So also following on the previous presentation from Claudio, we believe that the solution when it comes to traffic management should be a little bit more inclusive. We need to include pedestrians, we need to include soft modes. The solution cannot be only cars anymore. We want to change a little bit the narrative. And this is what we are trying to do with our technology. That as I previously said, we're leveraging both AI technologies and drones. Now a little bit on how we do it. First of all, we have a part of AI that is related to reinforcement learning and optimization of the drone routing. So we want to optimize the way the drones are going to fly and they're going to collect information. We talked with the cities, we understand their problems, and after that we use a swarm of drones that can fly over different parts of a road network. And as you see in the screenshot there, we can identify all the different types of vehicles. This is a computer vision algorithm, another part of AI, where every moving object on the ground can have a different bounding box. And that means that we can detect and track everything that is moving on the ground. And that includes not only cars, that includes buses, trucks, pedestrians, and bicycles, right? After we have their trajectories, we can identify we can estimate actually their speed, their acceleration, or their kinematics profile. And that means that at the same time, we can turn the drone into a high quality multi-sensor that we can estimate CO2 emissions, noise emissions, safety related features, and all of that without any infrastructure on the ground. Now, having said that, I should also know that all the data that we are collecting are privacy friendly because we do not see any faces, we do not see any vehicle plates. So for us, this is very, very important that we are promoting a good use and ethical use of AI as well. Now, I want to show a little bit how this happens in specific projects. So we can see here a very short sample video, just a little bit to get an idea of what we are doing with our algorithms. You can see how the different vehicles and pedestrians are being tracked. From this height, the quality that we are having is great. We have less than 10 centimeters of error. And a little bit to continue of how we are using this technology to tackle the challenges that we have in different projects. And for example, the Acumen project that we described before. As Claudio also noted before, one of the challenges we had is to collect the right data at the right location. So you can see on the top left of your screen how we were flying over the port of Helsinki in Finland, where our partners needed to know how many of the passengers that are exiting the port, how many of them are using public transport, how many of them are using the nearby parking or the bus parking that is there. And on the top right, you can see that we can extract privacy-friendly origin destination maps that are very, very detailed and quantified in different intervals. And also in the bottom right part of the picture, you can see how we can also count vehicles that were unloaded from the ship into the city's network. So while here, of course, I'm showing a video of only one drone, you can imagine that in the nearby area, there were 6 drones flying. So we were really able to understand the different, not only vehicle dynamics, but I would say mobility dynamics and how a disruptive event like the arrival and departure of a big ship can affect a city's network. And then I included this slide while in Delphi. We are doing different things that include AI, especially when it comes to logistics and passenger transfer. I included here an example from our use case in Mykonos, Greece, because there we have a similar traffic environment, but with totally different issues. Mykonos is an island in Greece, very well known for the high-profile tourists it attracts, and mainly the high peak seasons that it has during the summer. Right? There are not many sensors on the island to monitor either traffic or other mobility-related KPIs. So we were able to fly our drones again over the port. We are able to see how pedestrians are moving in the port and how they can affect operations or safety in this port. But at the same time, we had drones that were flying in the internal part of the island, and then we were able to see the latency and the effect that let's say the arrival of a ship has when it arrives at the port. And then give another example of how we are using this technology. This is again from the Delphi project, where we are using our drones to estimate emissions and road safety KPIs near a metro station in Madrid. The idea there is that we are using the metro, we are using pedestrians and bicyclists, last mile delivery people that will take a package. Instead of having truck vehicles entering the city, we are using the existing infrastructure to deliver these packages. And our idea here is that we want the people at the last part of the chain not only to care about the travel time and delivering the package as fast as possible. We want them to follow a route that is optimized in terms of how much CO2 emissions they breathe, how much they are exposed to noise, and also if the conditions on the nearby road network are safe enough, right? So we are using the drones in the that you can see on the left part of the screen, how we can cover a big area around this metro station. We can estimate all these different KPIs, and in the end, we're able to provide an optimized route that is not only fast, but it's also safe, health-wise, and road safety-wise. And I feel that this is the end of my presentation. I tried to keep it short, and of course, I would be happy to answer any questions later.
You did, Mano, and you finished with a fantastic conclusion that you are trying to route or contribute to the routing of not only what is the fastest in travel time, but also what is strategically important for the city priorities. And I'm happy to hear that your drones are, or your drones, the system that you data through the drones in traffic management is also able to, it's a high quality multi-sensor and collects also emission data, not only a location and identifying pedestrians and vehicles and anything moving. So thank you for presenting your excellent work. I will pass fast the floor to Charles Terito, Chief Growth Officer from Hayden AI. It's one of the two SMEs that we have in the panel, very innovative and very important use of AI for safety and passengers and accessibility in public transport. So Charles, if you request control from the top of your screen, then you can present your slides. And you can unmute yourself as well. Yeah? Does it work?
It does. I think my slides are, it should be working. Let me see. It says stop sharing.
If you go,
there we go.
Excellent.
There we go. Great.
Super,
well, thank you, Joanna. Thank you for having me, and it's really great to be on a panel with such esteemed other presenters. I think what we'll talk about today is more of a practical application of AI. What we've done at our company is built a purpose-built mobile perception system that captures and analyzes images and data. We include different hardware components like cameras to capture images and an edge processor to interpret and process those images, and then software that applies AI on the edge to power our analytics portal. Our system can be employed or deployed on any vehicle, but the first use case, and what I'll talk a little bit about today, involves installing the system on a transit bus to allow for enforcement of various transit lane and bus stop related parking infractions. When the vehicle is turned on, the system also powers on. And as the vehicle travels down the road, our cameras capture images and our edge processor gathers metadata like the precise location information. Each image and each piece of data that we capture is a single input. And our system applies multiple AI methods to these inputs on the vehicle itself in near real time. And then from that creates many more outputs. I think that the system that we've designed is obviously much more than just an enforcement system. But again, what we're talking about is a practical use of AI. There's no question that there are many theoretical ways to take this data and to use it. And many of those often get the headlines. But what we're trying to do is take AI, use our deep learning computer vision application to analyze and extract information in real time from the camera field or camera feed to enhance the transit network. At its core, our application uses convolutional neural networks in combination with advanced tracking technology to monitor various objects on the roadways over time. And those neural networks are trained on a large data set of images and roadways, really from around the world. As our system operates over time, capturing more images and increasing the size of that data set, the neural networks get better and our accuracy improves. One important thing to note is that our system only detects objects, not people. And we don't do any type of facial recognition. So what I'll talk a little bit about is how we use our system to make bus stops safer and more accessible. We were established in 2019. We are a vision-based AI company, as I said. This image has a couple pictures of our camera installed in this application, which is a transit bus. We automatically detect, as I said, bus stop, bus lane, bike lane, double parking, no parking. In the UK, things like red routes, yellow routes, or double yellows, all different types of enforcement opportunities. And the system is very flexible. I often say if we can see it, we can map it. If we can map it, we can enforce it. We have proof of concept pilots in several European cities, and we're under contract in the United States with 5 of the 10 largest transit agencies. Oops. You know, one of the big challenges with people parking in bus stops or blocking bus stops is that individuals who are in wheelchairs or individuals that need to use ramps to board buses aren't able to do so. And that's obviously a significant safety issue. Our tool is an application of AI that, for example, allows anyone to, or ensures that we can keep bus stops clear so that things like ramps can be deployed safely, that passengers can avoid having to step into active travel lanes to get on and off buses. And we create an inclusive environment that allows everyone to travel safely and independently. Here's an example of a video and a bus stop that's blocked from one of our buses in Washington, D.C. As you can see, the bus can't lower the curb for the person who's waiting at the bus stop who needs accessible boarding. That's a real safety problem and certainly a challenge for both the operator of the bus who is trying to pick up their passenger and the person in the wheelchair who's trying to get on the bus. And so AI has been able to detect the vehicle that's parked there and will capture the license plate of that vehicle and ultimately issue a violation to that driver. You know, we've had some significant results from our programs. In Washington, D.C., we've seen, for example, a 32% reduction in bus stop violations over a 1-year period. That reduction shows that there are practical ways to deploy AI that can enhance the transit network for all and can ensure that we have both equity but also efficiency on the roads where our systems are helping enforce traffic with AI. So with that, thank you all. We really appreciate being part of this discussion and look forward to hearing the rest of the presenters.
Charles, thank you very much for bringing into the picture the topic of equity and inclusivity. It's very important topics in the traffic management. And thank you for giving us the more, let's say, real life application of or practical use of AI in traffic management. So, okay. Oh, okay. Something is happening with the slides. It's very impressive also to hear the 32% reduction in bus stop violation in Washington, D.C. That's very good news. I would like to pass the control of the screen to Olga Gonzalez, who is a Vice President Marketing in Valeran, which is the other innovative SME that we have in our panel. Olga, you are working on the safety and real-time incident detection, and you're discussing how you're using AI as a tool. And please, let's know about your awards as well.
Thank you, John. It's a nice introduction. Good morning, everybody. My name is Olga Gonzalez, and I am responsible for commercial engagement and marketing at Valorant. So we are working in the area of data analytics for traffic management on motorways. And as Joanna just hinted, we probably have collected the entire set of industry awards for the work that we do. The latest awards we've got is EIT Toll Excellence Award and the European Union Excellence in Road, Toll Excellence Award and the European Union Excellence in Road Safety Award, and that has been awarded us for our work with TII, which is Transport Infrastructure Ireland. And literally a few days ago, we went out public that now Ireland is the first country that deployed artificial intelligence system for traffic management on the strategic network, i.e. nationwide. And that is done with support of European Space Agency. We use satellite data to harmonize satellite coordinates to GNSS to harmonize data for fast and more accurate data processing across, as you can imagine, a very, very large area country-wide. So that's about us, and let's talk about what we do in practicality. So as you can understand, we have a lot of data sources now coming our way with development of various technologies, connected vehicles, IoT, edge, etc. We have so much data that how to process data. Data is partial. Let's say if we look at camera is a great source of data. At a face value, you have what you see. But camera cannot see behind, camera cannot see in rain or fog or dark times, and camera can trigger false alerts because of raindrop on the lens. As well as data is partial. So data is noisy, such as Waze is a fantastic data source of data, but if any of us will pass by the same incident on the road, all of us will report it slightly differently, starting from the point because we are all different people, so we see things differently. So imagine yourself in the control room in traffic management center, where you have all this data from various systems that actually are not integrated into one interface and slightly telling you different sources. So here's the challenge. How do you effectively identify and verify an incident or real-time situation that's going on the road if you have to process it manually with your own eyes because you don't know what you can trust or what you can't trust? So as I mentioned, data is noisy, data is partial, but it's also, data is not homogeneous, such as you get phone calls, it's voice, then you have social media and crowdsourced applications, which are natural language or GIS coordinates, and connected vehicles as trajectories. How do you actually get all that data to process automatically? Humans can do that. We know how to make some judgments, but computers can't. So that is a challenge. You need to be able to process data in an efficient way in real time. And here's the power computation. So we call it data fusion, and data fusion is not taking data layers, piling them up in one stack and playing back. Data fusion is complicated, comprehensive, and very compute-intense process whereby we get all these data sources and get best of each data source and combine a complement with best of another data source. And this diagram is to demonstrate how we do it. So we take all data sources together and we start with cleansing data. So if we have two events at the same time, the same location, the probability from different sources, the probability is it's one event. So we eliminate some noise. Then we start cross-referencing with different data sources and different types getting to a point where if there is a pedestrian detected by a camera and here is telling you there is a congestion and Waze telling you there is a crash and loops on the road telling you there is a traffic jam, we will look at it and say, actually, it is a broken down vehicle. The pedestrian is actually the driver of that broken down vehicle, and the congestion that loops are telling you is actually the result of everybody slowing down to safely go around that affected area. So deal with that broken down vehicle instead of trying to understand, do you need to send somebody to understand what the congestion is about? Is there a crash? Do you need to send an ambulance there? And we also, again, after that, we put that into context that is important to every operator because driving styles in different countries or even different ranges in one country differ a lot. So let's take a stopped vehicle as an example. A stopped vehicle on its own is an event. However, if you put it into context, is a stopped vehicle on a hard shoulder or in a live lane? Live lane, is it a speed lane or slow lane? Is that stopped vehicle close to a sharp bend on the motorway, or is that stopped vehicle by a tunnel, or is it stopped vehicle on a straight road where you can have good visibility so you have time to brake and safely go around that stopped vehicle? All of these events have very, very different severity. And the numbers at the top of the slide demonstrate how much noise the algorithm is capable of eliminating, deriving to 7% of data out of 100 at the beginning of the computation. You eliminate 93% of irrelevant information, or you fuse that information into one. So that takes only 5 seconds for an operator to review and understand with their own eyes what's going on and take the correct decision. So I titled the slides, "Camera is not a universal remedy," because many conversations that we have, we hear, oh, we have good coverage of camera coverage on our motorways. So here's an example. There is a stopped vehicle in this picture. And the reason you don't see that stopped vehicle because it is just behind that road sign. And of course, there is an obstruction on camera view, and the camera cannot pick on that. So this detection has been picked with one alert, which is not camera, which is Waze. And the top right corner of the slide contains the rules that we assigned to this detection. First of all, it is in Greece, and we know that in Greece, Waze is not very much used. Therefore, the accuracy of Waze detections is probably higher than, let's say, in the US or the UK, because people randomly press buttons. Then combined with that sharp bend and very narrow hard shoulder on the motorway, the severity of a combined factors is quite higher. Whereas in alert, it is a true detection. There is another example. So imagine the camera is looking northbound and there is an incident southbound. How do you know about it? Because camera cannot pick it up. So here it is. If we got detections from other sources, we raised an alert, we alerted the operator turned the camera, and here we go. We have an incident. It's actually a crash. A vehicle crashed into service vehicle. Here it is. And as you can imagine, it's in a speed lane that is potentially very severe consequence. Another example, nighttime. There is a stopped vehicle in this incident with hazardous lights. Camera cannot potentially see that. Yes, you have good algorithms, and we have a good algorithm that is capable of detecting hazardous lights in challenging lighting conditions, but combined with additional alert by Waze, again in Greece, it gave us a confidence of 1, because we measure from 0 to 1, that there is a genuine incident. And again, put it into context, is a dark time, it will reduce visibility. It is only a matter of very short time that somebody will drive into that stopped vehicle. Then another example, camera is not a universal remedy. There is no camera in this incident detection because there is no camera, but it is a true incident. And if you can see, there is on the right-hand side, blue line that is beeping on the graph. This is the real-time speed that we measure, which is another confirmation point that you need to, for the operator, you need to do something about it because the speed, real-time speed dropped. So do something, send a patrol vehicle. I wanted to say that data fusion is probably the way forward, and I'm glad Claudio mentioned that we are moving towards soft traffic management. You cannot possibly have roads covered with infrastructure. It's very expensive. You can, but it's very, very expensive. It's very expensive to maintain. And we have so much data that is capable of telling us a very compelling story. We need to know how to process that. And I would like to finish with one thing, why we got the award with the TII deployment, because although TII have about 5 or 4 years old traffic control sensor, i.e. they have quite up-to-date systems, our deployment demonstrated that our system was capable, using data fusion, was capable of detecting incidents 25 to 35 minutes sooner on average, plus detected incidents that were simply missed by the TMC systems. And if you take that and that number and extrapolate to the size of the country of Ireland, it's 20 incidents per day, which is a very significant number. So that concludes my presentation.
Thank you, Olga. Thank you. And it sounds quite polemic, eh? A camera is not the universal remedy. And of course it's not, but you are referring to the static cameras and not the cameras,
no,
for example.
Too.
Yeah, that
it is that too.
Hayden AI is putting the cameras on the buses and any vehicle actually, and it's also very important to be able to collect data while the vehicle is actually moving with the camera on it. But okay, we can discuss all this at the end of the presentations. Thank you very much, Olga, and also for pointing out, explaining to us how you eliminate the noise in the data from well, you talked about 93% elimination of data noise, which is pretty impressive. I really like the very practical examples coming from Valera and Hayden AI, because now we have the opportunity to hear what the cities are thinking about it. What is their perspective on AI deployment in traffic management? And we have Sibyl Meffre from the Police Network to tell us all about it. Thank you very much, Sibyl, for joining our panel. The floor is yours.
Thank you, Joanna. Thanks a lot. Yeah, so I'm here to give you the perspectives of cities. So I'm part of Police Network. So we are a network of more than 100 cities and regions in the field of sustainable urban mobility innovation. For them, we foster peer-to-peer exchanges between cities. We help them navigate the European policy landscape and to be part of European projects. I'm also part of the Acumen project, working with Claudio on this. So our work at Police is divided in 5 topics, and I'm part of the Traffic Efficiency Working Group with Laura Babio. So we organized a meeting at the end of September focused on AI, so we could have some really interesting discussion directly with cities that are trying to implement AI in their traffic management system. So first, I want to give you some examples of the use of AI by cities. So indeed, I don't have a lot of time to deep dive in the different examples, but so you have a bit a glimpse of how it's used. And indeed, there are some examples in other cities that cannot be mentioned today. But so in terms of traffic management, there are different components on where AI can be used. But we had the first interesting example from the cities of Amsterdam Here it was on traffic optimization, especially on the use of traffic lights. They are using AI to help to face simultaneous objectives when, for example, traffic lights needs to understand who has the priority between cyclists or pedestrians. Another example is on the traffic prediction. Here it comes from the Transport for Greater Manchester. They are using AI in the analysis of historical and real-time data to predict the traffic condition up to 1 hour in advance. So here it's really about helping to analyze a large amount of data. They're also using AI in different ways. I'm coming back to the example of the Acumen project and the Helsinki city because AI can foster multimodality. Here, AI is used to integrate data from several modes of transport in the Harbor area, the Jätkäsaari area. So whereas Claudio explained, there are data from passenger ferries, data from micromobility, from the tram, and how to make it really smoother. Also, example coming from Michelin in Belgium. Here it's about the traffic safety, and it was especially using AI to assess the safety of cycling path. So it was using some AI tools to collect the data and to especially images, and to analyze the images to understand where the city must intervene to be sure that the bike path is safe enough. Another example, not on passengers, but on freight traffic management, that is really really important in urban context, is coming from Gothenburg, and here it's how to optimize loading and unloading zones with real-time data and to make the deliveries more efficient and sustainable. So here I could give you some real benefits of using AI for cities. But indeed, those benefits comes with a lot of challenges for cities, and we are trying to understand what could be some pathway to find some solution and foster the use of AI. So first challenge is indeed the capacity of the city. There is an issue with the technical capacity. It's often hard for cities to develop in-house solution. They don't know if they want to rely on proprietary tools coming from major tech companies, and they often prefer to use some open source tools. But here come also the issue with the financial capacity. It costs a lot to acquire AI tools to do the data collection, the data processing. There is always a need for a clear ROI to be sure that it's going to be accepted by the governing authority. Here, they can be helped with some capacity assessment tool to understand at what points they are. There is an interesting one that is developed at in the Acumen projects. There are also interesting tool developed in the International Transport Forum that I encourage you to go and see. There are also challenges with the data availability, both in terms of data quantity. It's often insufficient data volume that can be available to train the AI models. Issue also with the data quality. In the cities, you often have inadequate formats, still PDF, and there are still a lot of work to do to use those data. Here, there can be some solution with some private-public partnerships, increase the volume of data, understand how we can gather more and of a better quality. Another challenge is indeed the one of governance. So who is going to manage the use of AI within the traffic management in the city? And the cities need more clarification in the decision making. They need help to build a proper governance framework. Here, it's also one of the objectives of the Acumen project. And another challenge is, but maybe one of the biggest one for the cities, is the public trust and acceptance. There needs more transparency. The citizens want more transparency on the tracking of the AI use. They want to be reassured on the data privacy. So here, really some clear ethical and privacy safeguards are needed. And also that's one other reason to emphasize the need of the human in the loop. So as Claudia mentioned already. So you see that there are many prerequisites to make sure that we can redevelop this use of AI in cities. There are a real need for 3 parallel transformation, institutional transformation to convince the local authorities, the politicians. Cultural transformation, also cities needs to be more data driven. There are really differences between cities according to the size and to advancement and to the capacity, and there is indeed a technical transformation, either hire more data professionals or contract with third-party experts. To conclude, I wanted to share with you this figure from Amsterdam. So it's coming from their strategic vision of AI that they published. To really understand what's still the philosophy for cities of what's the place of AI. So if a city wants to use AI, the human must remain central. Also, the technology can really bring a lot of benefits, but it should not be used only for the sake of using technology, but really to meet the citizen needs and to be sure that we always respect the public values. The whole traffic management system from a city net should be defined by the technology, but really of the objective it aims to achieve, and then AI come only as a support. And also to mention that some cities are concerned that if there are some issues with the data, if there's some bias, then it will be like just amplified by the use of AI if it's can be a bit out of control. So we'll be really cautious on this. Also, there are some cities who raised the concern of the energy consumption of AI that is really not aligned with their goal of reducing CO2 emission. So here, my final message would be like, yes, cities are really interested in looking into AIs. It will help them automatize a lot of repetitive tasks. It will help them to analyze data faster and better. But AI can never really replace the human intelligence. For now, the humans still need to be in the loop to be sure that really AI meets its goal to serve the citizens. Thanks a lot.
Thank you, Sibyl. I think what you're bringing to this discussion is very, very important because, yes, we are all fascinated by AI. We're working in traffic management, making traffic management procedures and processes and tools based on AI and our life easier. And we're trying to actually make the life of the users easier as well. But then we need to understand the perspective from the cities. What you were talking about, this vendor lock-in from the technology side or the lack of know-how by the cities, and the prerequisites that you showed are very, very interesting. This institutional change, cultural change, and the other one was technical. Absolutely. And the point on the energy is really interesting. Let's discuss it when we have the discussion time. But thank you very much, Sibyl. Very important contribution. Let me pass to the next speaker, who is Caroline Matzal from TomTom, the TomTom Group. And Caroline, we are working together on the TM 2.0 platform, and we're discussing about the AI Act all the time. So I leave it to you to give us the TomTom perspective and let us know how TomTom is using AI and how does this link to the high risk or not of the AI use in traffic management. Thank you very much, Caroline. The floor is yours.
Yes, thank you so much, Joanna. So I'm very happy to present to you today and indeed also take the perspective a bit on the AI Act and what it means for our sector. So Caroline Matzal, as said, Manager Government and Regulatory Affairs at TomTom. And I'm going to tell you about how we get from data. And as Olga mentioned before, there is an enormous abundance of data, but how do we get to the right decisions and do that in a responsible way to enable real-time traffic and travel insights? But first, let's take you a little bit down to memory lane, the history of TomTom. Everybody knows us probably best from 2004, where we invented the satellite navigation device, of which we sold more than 100 million worldwide. But in 2009, with the introduction of the smartphone, we had to pivot from our business to consumer business to a business to business enterprise. So we went from that moment on inside the vehicle. So we became an embedded system, and we were selling from that moment on directly to the automotive industry, so to the car manufacturers. And since then, we're providing not only automotive companies, but also enterprise companies with 3 product groups. First of all, the digital map, which is the basis of everything. Then navigation software that we put on top of the map, and our very famous traffic and travel information, which I will be talking mostly about in the next 8 minutes. But yes, we've heard the AI Act, and it actually has a tremendous impact, or it will have, on the traffic management industry, because in the high-risk sector, which means you have to assess the products very well before they are put on the market, there's a mentioning of AI systems intended to be used as safety components in the management and operation of road traffic. So this is marked in the AI Act as a high-risk application. And we are still trying to figure out what it actually means, because it has still a lot of uncertainty. What are AI systems in the context of traffic management, and what is exactly meant by safety components? And it can have a prohibitive effect of innovation in the sector, because, yeah, it creates uncertainty. And we're still waiting for the implementation guidelines that have to come from the AI office. And indeed, like Johanna was mentioning, we're working very hard in the AI Act task force in TM 2.0 to work with the Commission, and especially the AI office, to make sure they make very clear and precise guidelines so everybody knows what they're dealing with. So then moving to TomTom and how we build our live traffic and hazards products that are used by traffic management centers, but also by drivers to give them information. So indeed, there is a plethora of data out there, but of course, the most important thing is what you do with it. But let's first look at the input sources. So we use diverse sources to make sure that our data is accurate, and these sources can be mutually reinforcing. So in the old days, we used mainly probe data. So these are the 600 million connected vehicles of which we get the GPS traces. So we get daily about 61 billion data points from all the cars around the world that are connected to the TomTom system. But due to AI, we can add a lot of different sources. And we have, for instance, as input sources, journalistic data. That's the data also that's coming from the road authorities and which are getting better and better. Then the newest cars are driving cameras. So this also gives us eyes on the road, and a lot of eyes on the road that we match with our GPS probe data. Then we have active community input that's collected through our apps, but we also have the human in the loop. So that's what we call traffic moderation. These are actually 30 people around the world that if they see there is an anomaly, they go and check if that information is correct. They try to get the right sources on the ground. So from there, it goes into our fusion engine where all the magic happens and where we add more and more intelligent and advanced machine learning tools. So we deliver then 2 large products. So one is the traffic flow. So this brings insights on how quick traffic is moving on certain road segments. So average speed and travel times per road segment. And the other product is traffic incidents. So this is really what's the calamities that happen on the road, the hazards, traffic jams also. But let's look a little bit into real life use cases. So first of all, as said, we deliver live traffic services for traffic centers. So for instance, the traffic flow product that I was talking about gives a person in the traffic center information on how fast traffic is moving on different parts of the road. And if they see this is slowing down, they can take active measures, so lowering the speed to prevent the traffic jam from developing. And the other use case is when the traffic manager sees that the road is completely stopping on a road segment, they can check with camera data what is the cause of it, and they can take measures to closing the lanes or maybe even a complete part of the highway. So this is giving them decision support, but they are in the end still in the driver's seat to make the decisions. But as mentioned, this doesn't only go to the traffic management centers. We also deliver this to our drivers because it enhances their safety. So traffic hazards are highly dynamic things that are happening on the road and which we deliver within 5 seconds to the driver. So this is categories like vehicle incidents, warning people about traffic jams, jam trail warning, broken down vehicles on the road. And lately we've been adding emergency vehicle approaching, a highly stressful situation for drivers, and also a wrong way driver. So these are highly time critical and very dynamic incidents. Then there are more static incidents or road hazards that we call it. It's bad road conditions like potholes, objects on the road, roadworks, very important. We try to get that as good as possible. And we are working a lot with the traffic authorities to make this more real time and have the right information at the right time. And also we have road weather hazards, things like slippery road, strong winds, especially relevant for trucks, reduced visibility, and as we have seen, it's becoming more and more widespread is natural disasters like floods or fires. So I'm coming to the conclusion from what we have seen, also not only from me, but from all the presenters, I think we can conclude the following things. That the way AI is currently used in traffic management, it enhances the quality of a lot of things. And in our case, it enhances tremendously the quality of our traffic information. Second of all, we've also seen, and it was very interesting to see also the research project, that responsible AI can have huge benefits for road safety, but also for sustainability. So I think all the applications we've seen are evidence of the way we responsibly use AI in our sector. And third of all, AI is a support tool. So it does not replace humans. And in the case of the information going to traffic management centers, it's still the human who takes a decision. And in the case of the car, we can warn, we can inform, but in the end, it's still the driver that takes a decision. And a lot of people know this. It supports them, it enhances their driving skills, but it doesn't replace them yet. I'm not talking about the far future, but at this moment, that is still the case. So I would say from this that the way we currently use AI in traffic management, we should not consider this as high-risk AI. Thank you so much, and I give back to Johanna now.
Thank you, Caroline. Perfect conclusion. It's not high risk. And also it's not high risk, but that's what our argument is in the TM 2.0 platform. And I think representing the entire traffic management community, because it's not, traffic management is a process. It's not an AI is a tool stepping into the different parts of the process and aiding the end decision making. So thank you very much, Caroline. Let me pass fast to Dr. Bart Lano, who is the Innovation Director from Be Mobile, also a service provider, the same category of service providers like TomTom. And Bart, you are going to talk to us about some real life examples on how you use AI in predictive traffic management, correct?
Yes, indeed. So
the floor is yours.
Thank you, Joanna. So I will present you some applications we do with AI-based travel time predictions. So Be Mobile, we are also a service provider. We have some similarity to TomTom, but we also have some other focuses, of course. Be-mobile is mainly active in the Benelux, Belgium and the Netherlands. It started 2007, Be-mobile, mainly with a traffic information service provider, but in the meantime, we're also doing work on traffic management, a lot of traffic insights and so on. The work I will present today is also embedded partially in this European project Synchromode. So it's just like the Acumen project that was already presented today and the Delphi project as well. So it's from the same round of Horizon Europe goals, and in Synchromode it's also focused on advanced solutions for traffic management. Yeah, so what I want to present is a few test cases we did at Be-mobile within Synchromode. So it's one for the Keukenhof. So that's Keukenhof is the large tulip festival, I would like to say, in the Netherlands. So it's 6 or 8 weeks in spring, where a lot of tourists are going to a small village south of Amsterdam. And which causes a lot of traffic and traffic congestion. Another case is on sunny beach days, also in the province of South Holland in the Netherlands. Also there, at some busy days, some sunny days, then it can be really busy. And what we want to do is based on predictive analysis to see how can we inform our users much better. So at Be-mobile, we also have a navigation application, Flitsmeister, mainly popular in the Netherlands. So in the Netherlands, Flitsmeister has 3 million users on a monthly basis. So that means that we can reach a lot of car drivers there. And we want to see, can we make our travel time predictions much more reliable by using AI? And this both on a short-term predictions and more long-term predictions, which I will explain in a minute. In the end, the goal is to keep congestion more to a minimum. Of course, some similarity to what Caroline was also presenting for TomTom. Let's move to the next slide, where I will give some more explanation how did we do it here. So it's first of all, this work was also together, so in the Synchromode project with our Greek colleagues from the Hellenic Institute of Transport, which is part of CERT. And a first prediction model, but I see there's something wrong with the slide, but okay, I think everything is more or less on it. So we do some short-term traffic flow predictions with a spatial temporal graph convolutional network. So it means that both spatial dimension and the temporal patterns are taken into account. So place and time, more or less. And on the time aspect, so from the temporal aspect, we do predictions 15, 30 and 45 minutes ahead, really to have a good view on what will come soon. On the graphs, I don't know if you can read everything, but what's here shown is on the left side, it's on a segment base. So these are just road segment, 50 meters, where we do these short-term predictions. And then this is combined also in route predictions on the right side. And there the blue curve is in the end the true so the situation in reality, and the red curves were the predictions. And you see that predictions are following quite well the reality, and even at some peak moments in reality it was even more busy than predicted. But okay, the models are also still under, yeah, they are it's work in progress, but you see that it's already working quite well, and it's already showing some reliability on that as well. Next to the short-term predictions, we also did some long-term predictions. It's another type of AI or machine learning model, more on classifying the different days. So it's up to 5 days ahead, and we take into account different parameters. So a lot of data is available. On the one hand, there are the travel times. So we have a lot of historical travel times in the areas that we were considering, but you can add some other features as well. For example, calendar features, seasonal terms like, okay, we know this is a public holiday, so the chance is larger on having more traffic. It's a weekend day compared to a weekday and so on. And then also weather forecasts. So where we different parameters of the weather forecast take into account. And then we can classify the days up to 5 days ahead on, is it a busy day or will it be non-busy, and with also a probability score, so that we have a much better view on what to expect the next days. And how we will use this now, this short-term and long-term prediction. So at BeMobile, we have, it's a traffic campaign platform. So we use it for in-car communication, so in-car traffic management. This platform can, for example, be used by local road authorities, by cities and so on, if they want to warn on some busy roads the drivers, for example, through Flitsmeister, but we can connect to other apps as well, and giving them the right message if they have to expect something. So it's both post-trip. Post-trip means when somebody often take that route, that you will be warned in advance, and on-trip is really during your trip. And then messages like, we expect a lot of extra traffic on a certain day due to Keukenhof, and then people can be prepared, okay, and maybe take alternatives if they have to be there that day. So it's make our drives much more prepared, and in the end to lower congestion because of this kind of measures. But it can also be more short term. So between this and this hour today, be careful, we expect a lot of traffic, plan maybe your departure at another moment, and so on. And then for the on-trip example, for example, here, the beach day in the province of South Holland, Noordwijk, we give real-time advice as well. For example, can be very crowded, and it's maybe better to go to one of the parkings and take a beach shuttle there instead of driving really to the beach. And if you have these predictions, for example, up to 45 minutes in advance, then you can much better steer your traffic, and instead of a reactive approach, you can be more proactive. And then another point is, but here, yeah, the graph is not like I had it initially, so there's something with the layout wrong, but I guess it's more or less clear. But we give also some messages on when congestion is expected. On days when there is no congestion expected, no messages were sent. On the other day, we sent several messages at some specific location. This was for Keukenhof here, specific locations in the neighborhood of Keukenhof. So, and it maybe more or less, like Caroline was also saying, this AI is really used as a tool for decision making and for assisting and making better predictions. But humans and drivers are also still in the loop here. And it also fits in the general BeMobile vision on optimizing your mobility. And we are then in between, on the one hand, the driver services, and on the other hand, the public road authorities that wants to optimize the traffic. So as already said, this kind of traffic campaigns, they can be managed by the public road authorities, and we make sure that the right messages is coming at the right place at the right time at our driver communities. So, and this concludes my presentation. Thank you.
Thank you, Bart, and I apologize. Your slides, I don't know what happened. Somehow the pieces moved, but I think it was clear for all of us, and I think you're doing a great job in BeMobile. So it's also a very important aspect that you're bringing on the table, and this predictive, proactive traffic management that is aided and enhanced by AI. Very interesting indeed, and I love the two examples because I live in the Netherlands, and these places are next to my house. Okay, so let me pass now to the final speaker, and then let's try also and have some time for the discussion and the questions. And please do use the chat to pose your questions. Let me pass the floor to Orestis Trasanidis, who is the coordinator of the AI community in what we now call 28 Digital, which used to be EIT Digital. And Oresti, thank you very much for co-organizing this very interesting webinar with me or with us. And please tell us, give us your reflections from the point of view of, AI-based innovation in the transport and mobility field, and what you are actually working on in this AI community. Oreste, the floor is yours. And if you request the control, maybe the next slide is more, it's not Be Mobile. Or shall I do it for you? I'll do it for you. Don't worry.
Thank you. It's
Thank you.
only one slide. So, good morning. I will be short. And if you didn't understand it, Joanna told me kindly to be very short in how she introduced me, and I will do that. I will follow her advice. Good morning from San Francisco. And it's 3 a.m. here, and I want to also give the credit to Charles for being with us today and staying long. I mean, to be part of this webinar. Really great to see you. And that proves also a point. AI is real and keeps us awake. Awake. This is how real it is and how important it is for our lives. All the presentations were fascinating. Just to add and to clarify, we're representing the EIT. 28 Digital is leading the EIT AI Community. We're representing all the knowledge innovation communities of the European Institute of Innovation and Technology. And we have formed an AI community for innovators and startups. So I promise to keep it short. So I will ask you to remember three important numbers. One is that in Europe, we have low adoption of AI. It's close to 30 or 40%, something in between. Is it the case in the other continents? It's not. So it's more. From 60 plus percent to China, to 50% in US, and we can go also to other countries and see that the adoption is faster. Second, how much we trust AI in Europe? Not enough. The same AI that the other continents are using, only the 35% of the Europeans fully trust AI as it is today. When in the other continents, as I mentioned, it's much higher. I mean, especially in some countries, I was looking at some numbers, reaches the 80%. Why those two things are important? Because without them, we cannot leverage on what AI can give us. All the things that were presented today. And this is important because some of the speakers discuss about the regulation. Yes, it's there. It might be an obstacle or seemingly one, but it provides a framework to improve the trust, to increase it, and so the adoption, which is important. And in this presentation, we saw some solutions that really break crossing borders and penetrating the different regulations. So we shouldn't look at this in a negative way. And again, I don't want to put him on the spot because I know very well what they were doing. I will think about the hidden AI, different regulations in different states in US and in different countries in Europe. They're making it happen. So the regulation shouldn't be perceived as a problem, more as a catalyzer for us to make sure that we have a trustworthy AI and make sure that we will adapt it fast enough in order to have all the potential for our cities, improve the services in them, and make all the operations more efficient for the citizens. I think this is my key message and what we have learned the last years by working with SMEs and the public sector. And I will leave it like that. And maybe the floor is yours again, Joanna, to open the discussions. Many thanks to all of you. 100 people for 2 hours. This is impressive. Thanks a lot.
What time is there? Can you tell us again?
3 a.m.
AI is keeping us awake. Fantastic statement. Thank you, Oreste. Thank you also for giving us these very interesting numbers on the low adoption of AI in Europe. Of course, these numbers are AI in general, not traffic management, but you have a very, very important point on the trust and trustworthiness. And I think a couple of speakers also mentioned it during the presentations about the trustworthiness and the how do you call it, the transparency of AI. Maybe that is a good question to start, and allow me to pose that.
I will ask
Yeah.
one thing, Sonia.
Yeah.
I would highly advise the public authorities in the audience to really engage with our speakers, to find opportunity to speak, to understand what is happening and how they can really leverage. They need to break the silos. This is really important, and this is why the webinar is really useful for everyone. Thanks a lot again. Sorry for this.
No worries, no, Oreste, but this is exactly what Sibyl was talking about. There is this. There are these changes that have to happen on the cultural, institutional, and technical levels in the cities, so that the cities feel more trusting or become more trusting towards the use of AI in traffic management. And I would pose this question on reflections on a transparency of AI and trustworthiness to the speakers, to the panel, and I would invite the speakers to comment if they wish by turning on your camera and your microphone. Super. Thank you, Caroline.
Yes, I would like to react to that. Actually, yesterday I was at the AI summit in Eindhoven at the Brainport, and there someone presented some research that found a correlation by how the better somebody understands AI, the less their trust is. Which was for me very interesting. So I don't know the source of it, but it came from quite a reliable source. But they presented this correlation. So how better someone understands, how lower the trust is. And then seeing that in Europe we are maybe a little less trustworthy. Maybe it is because there is a high level of AI literacy and we understand AI very well here. So just throwing this into the mix and looking forward to hear some comments on that.
Literacy, okay, wow. Yes, I have Manos and then Olga, and I don't know if Charlie and Joanna want to speak as well later. Mano.
Yeah, Joanna, just a very short comment. Indeed, it's something that when we talk with people in different cities, it's something that we hear a lot, because from our case, it's not that, let's say, we have to fight about the narrative of the AI tools we use, but also we're using another disruptive technology, which is the drones. And most of the times they're being, let's say, infamous for the attention for all the negative kind of publicity. So we're also trying to change the narrative there, saying that yes, we should be cautious when we have a new technology, when we have new tools that are being introduced, but, and then there are the arguments on why we should use it. And something that we've seen that really is a game changer is that all the data that we are collecting and we are using internally in our analysis to show some solutions to the cities, in the end, we also give them the raw data that they can use for any other purposes, and they can also be used for open science. And that is something that they really appreciate, because it's not like, we're doing like a one-off project and then we're doing the analysis and ciao. No, the data can stay in the local communities and they can be used by local institutions to do any more analysis. And it's something they appreciate. And honestly, we see even physical changes in their faces, when we give them the data openly, and there is a trust that is being built by this very small, simple move.
So it's the experience with working with AI that is going to help with the lack of how did you call it, illiteracy, Caroline? Yeah, okay. Olga, what are your thoughts?
Well, I think it's down to education to everybody, to wider public. I come from a mathematical background. To me, it is what I studied for 6 years at the university, and I kind of understand what it is about. But general public, I think, got a wrong perception of AI. AI is a statistical tool. It's just a supporting tool for decision making, nothing else. And what we need to do is educate people and really explain them that it is a statistical and then supporting tool. It doesn't remove a human from the equation. But we also have to be transparent with the logic that is embedded into applications that will enable trust, facilitate trust for users, because if you explain them what parameters have been taken into account and how, then people will see this is not something that is trying to take over my decision making, and I understand why I agree with the logic of this tool.
Yeah.
It shouldn't be black box, in other words.
It should be a white box. Yes. Thank you, Olga. And I think that's also what Oriana supports at the discussions we have at the CCAM associate partnership. Yeah?
Yes. So trustworthiness is something that is true. So we need to really understand what trustworthiness is and where we can reach into, depending what is the black box that we want to convert in a white box, because sometimes it's not possible because the nature of the algorithm that is inside. So it's what Olga said. So it's a statistics. That's why when I started at the beginning, I said we are doing nothing that we were not doing before. It's another way of applying statistics to see what is going to happen in the future. However, we have just finished an trustworthy AI on CCAM project that is called Atena under the CCAM partnership, where we have tried to the black box, or at least give some kind of extra layer of interpretability or whitening these black boxes. And one thing that we really think that is going to be helping is the reasoning. So sometimes it's very difficult to say to tell why the algorithm is doing what, or in which layer is happening what, because there are some. It's for a human interpreting it is very difficult. But having the reasoning behind, so I'm seeing this because this and this are in this. So putting that in natural language where a human can interpret will help a lot to a decision-making person who needs to take a decision based on the data that has been processed under a black box that is getting some kind of outcome for them. So if this outcome is somehow accompanied by a reason, so this is because the last time that I saw this pattern happened this, and this can help a lot. So a kind of giving extra information to help understand what is going on and why this decision is suggested. This is something that will help in the future, and this is what we have seen in our Athena project.
Thank you, Oriana. And Charles, you're having real life experience with this, working with citizen enforcement and so on. Yeah.
Yeah, I think I have kind of three things to touch on. One of them is what Olga talked about with transparency. I think transparency is very important. We try to do everything we can to explain to our customers what AI is and what it isn't. And we want to make sure that there is a clear understanding of how our technology works. Certainly, when you use a vision-based AI, there is the potential for individuals to believe that you're somehow manipulating those images or using AI to create something that isn't there. And so we go above and beyond to make sure people understand how our systems use. The other thing is something Orestes said. I think that regulation can certainly be a challenge, but it also builds confidence. And so policies like GDPR, other types of policies like in the UK, VCA, I think build the confidence that the systems we're building are following a certain set of rules. And the last thing is probably that just like anything else, we're really selling the problem that we solve, not the product. I'm not selling AI, for example, or offering AI. What I'm offering is a solution to enhance mobility. And AI is a tool that we can use to do that, just like a traffic light is a tool that can be used to direct traffic. And so, you know, I think that if we focus on those things, if we stay transparent, if we have good regulations, and if we focus on the outcomes more than how we're using certain tools to get those outcomes, we'll be able to be successful in deploying new technologies like this.
Thank you, Charlie. I'll go back to the regulation, but there are a couple of questions on the chat. The first one is, does AI-based traffic management model also account for infrastructure health factors like pavement quality, markings, or lane degradation that directly influence traffic flow and safety? So that, who would like to answer this question? Is Olga, are you raising your hand for that? Okay.
I can answer that question.
Sure.
Yes, it can. It is a data stream that can be taken into account for modeling. So it's just a matter of how, you know, what the model takes into account. But yes, it is possible. The more data, the merrier, put it this way.
Yeah, of course. And Charlie, yes?
Yeah, the only thing I would add is that, you know, we're actually using our vision-based AI to begin to look at different assets and report on those assets to the cities we serve. Certainly when we have cameras traveling all around, we can detect things like potholes, we can detect things like missing street signs, we can detect things like roadworks, whether they're permitted or unpermitted, and having that data in real time, being able to refresh that data multiple times a day is invaluable to agencies as they try to understand what's going on their roads throughout the movement of vehicles from morning till night.
But thank you. Can I ask another question to Charlie and Olga then? So is this a set of data that you pass to your city authorities client anyway, or do they have to ask you to pass it? So you detect on the motorway, you detect Olga, or Charlie, you detect an urban context predominantly, and is this going along with the general data that you're passing, or is it on order, on demand, let's say? The infrastructure health, yeah.
Yeah, for our company, it can be either way. We've developed a portal that our customers can use to see historically over time where different things are occurring on their network. They can see all the different instances, and they can very quickly pinpoint where they need to address certain infrastructure challenges. But we also can just provide a raw feed of that data through an API that allows them to fuse that data with other tools that they may be using.
Okay, thank you. And Olga?
For us, we don't take this data because we take traffic-related data, and road imperfections, I'd say, can be detected by anomalous slowing in traffic or frequent lane changes. So there are the means to detect the ease and anomaly on the roads. So we so far did not embed this information. That said, it doesn't mean we can't. It just our customers also did not require that because we've been focusing on incident detection, not the cause of the detection of the incident.
Sure. Interesting. Okay, and I wanted to also ask Manos if the drones that you're using are definitely identifying moving elements or things on the road network, but can you detect such? Yeah, of course, you are flying, what, 150 meters above ground? You can detect something major, probably in the infrastructure health, but not the maintenance stuff. probably.
Exactly. So for our case, it's something that is being brought up every now and then from cities, whether the drones can also be used for that. While there are companies out there, researchers that are dealing with this kind of topic, it's not something that we are dealing with as mobilists. But having said that, we are able to detect not only causes of congestion, but also causes of unsafety. And this might be related that, from mobility patterns that we can understand, or from estimating some surrogate safety measures. We can estimate parts on the network. We can identify those parts of the network that are dangerous before having the accident happen. So something that we see in the literature or in practice out there is that we're waiting for many accidents to happen to go and intervene and see, okay, something's happening here. We're trying to improve our methodology in terms of identifying the dangerous situation before the accident happens, and also in a privacy concerning way. So I would say that in a way we can merge all these different technologies based on each city's needs. And whether the drone, one time can fly at 120 meters for traffic purposes, maybe one of them, it can go a little bit lower, collect some more data, and someone else can use them for other purposes. I see the future of AI being that's in the part of the data fusion, collaborating and trying to optimize at the same time resources for the common good.
Fantastic. Thank you, Mano. And Charlie, you want to also add something?
Yeah, I just wanted to take a second. Maybe I could take control here. Can I show something on my screen, or do
Sure.
I need to be in the
no. That's
Can
difficult.
you see that?
No.
You can't see?
Then
Okay.
you should be sharing your screen, and I don't think we can actually. Yeah. But
Okay,
please
that's
describe
fine.
it to us.
I just have a video, and if anyone goes on our LinkedIn page, I think we just posted a video the other day that showed an example of us collecting data on things like potholes and street signs and other objects that in other assets that give a pretty good illustration of how we're using our tool to provide feedback on those assets to the cities where we're deployed.
Okay. Oh, perfect.
I think might be possible now, no?
What do you mean?
To share.
To share, yes.
Let me see. Here we go. You're right, Orestes.
Okay. Yeah. Pothole detected, gravity detected. Interesting. Yeah. Super. Thank you. We have another question, which is very interesting, coming from Carol. And I expected that. How is data bias being addressed? A very important point. If AI is using data that is biased, the result solution may create a negative situation in traffic management. ? So, Mano. Oh, I'm sorry, Charles, is your hand up for this question, or it stayed there from the previous one? No. Okay, Mano. Mano, the floor is yours.
Yeah, I will try to be very, very short here. I would say that the quick answer that came to my mind is that it really depends on where, in which part of the decision-making process, the AI is being applied. Because, for example, in our cases, when we are coming to count vehicles, I can definitely tell you that the algorithm, let's say, can do some mistakes, but it cannot be biased, right? However, when we see current practices, when we are using manual counters or loop detectors, sometimes there can be a little bit of bias. So I think we always have to put it in scale and see what we are getting and what we are losing. But as a quick answer, yeah, let's see where we're putting AI to take a decision and which part of bias is it included there. And then I'll pass the floor to Claudio, because I think he also raised his hand.
Yeah. Thank you.
Definitely good point. That was one of the points I wanted to also make, the one that Manos made. That of course, it depends where the bias comes from. One part of the solution that we are dealing with within Acumen, and I think it's quite important, is that, of course, this AI model cannot rely on a single data source. So we need to look at different data sources, and of course, the different data sources may each of them have problems of biases of again inconsistency. But when we then try to put them together, we try to address this, so that one data source maybe helps canceling the bias of another data source, and that's something that we are basically try to work on and understand better.
Perfect. Thank you, Claudio. Bart.
Yes, about this bias, okay, it's not only just an AI problem, it's we are facing it already for years, I would say. So, for example, we have a lot of floating car data. If we see, and we had it in the past, maybe in one of the countries, that there was too many trucks in the data, and then okay, your speed data is not anymore correct because it's biased by these trucks. So it's always important to monitoring the data, to have some feedback loops and so on. And of course, it will also influence your AI, but it's not only a problem of AI. So it's when you are using a lot of data, you have to make sure that you do monitoring well, having feedback loops and so on.
And it's, I think, as long as we, the people that are creating the algorithms and the systems and working with AI are aware of this danger, Carol, I think it's important that when we design something like this, we actually make sure that they are, we prevent this from happening as much as possible, and we learn every day. I think we have 3 minutes left, and I should be thanking everyone. But before that, let me take another question very fast. It says, I'm interested in how AI can best be used for economic system optimization, specifically in public bus transport. We have very complex systems that are mostly based on experience and traditional conventional traffic modeling, with shrinking public funding and resources, driver staff, etc. I think we could get significantly more of the system by using AI. Would any of the speakers care to comment on this economic system optimization, one of the benefits that AI is bringing into traffic management and transport? I think it's more of a statement that we all agree with, rather than a question, to be honest. Okay, I'll go to the next one. As reported by Olga, camera is not a universal remedy, and I fully agree with the statement. The question is, should be CITS and CCAM an improvement for traffic management using AI in major road network as complementary input? Any comments?
I guess it's a question to me. As I said, the more data, the merrier. So every data source has advantages and disadvantages, as I noted on my slide. So, and the more you have the best of every data source, the more complete picture is. So as I also usually explain that, if imagine you have to investigate a crime scene and you have only 2 people to question or 100 people to question, your understanding of what happened is very, very different. Now imagine you can do it in real time.
Yeah. Thank you. I think we only have 1 minute left. I think it was a good discussion, a short one. We can have a longer discussion online on LinkedIn under the postings, and you have the names of the colleagues of the speakers that accepted to join the panel, and I thank them very, very much, bringing their expertise, their core business on the table, discussing all these details. So now we know much more about AI in traffic management, in the use of AI in traffic management. I hope we have achieved a wider understanding on the benefits of AI and on the fact that the more we know, maybe the more we trust. And I thank you for joining. I thank all the participants for joining. I thank 28 Digital for co-organizing this fantastic webinar. And of course, I'm thanking the 9 speakers that joined the panel. Thank you all very much and have a very good day and a very good weekend.
Thank you, everybody.
Thank you. Thank you for
Thank you.
organizing. Bye-bye.
Bye.
Bye.
Thank you. Bye-bye.